Obviously, this is a kinetics question. You don't need to be a rocket scientist to see that. And the first question usually is, demonstrate graphically that this is a first-order reaction. Right? So, how would you address this first question? Demonstrate graphically that this is a first-order kinetics. Anton, what do you think?
Well, you can start off by plotting reactants versus time to see if it's a zero-order reaction.
Nope.
You could do that.
You could do that, yes. You could do a lot of things. But why would you want to do that? What would you do?
Write the rate equation.
Write the rate equation? Yeah, okay, good. What else?
And then open it up with
You draw an ln versus time plot. Right. Why did I shoot you down?
Because I was talking about zero-order reaction.
You were talking about a zero-order reaction. I already told you it's not a zero-order, so why would you want to do it?
Yeah.
You're wasting your time. Yeah? So don't give me something that I'm not asking for. Got it? It is a little bit like when you go to a restaurant and you order some, fajitas or something like that, and the waiter comes with a pint of milk. It's nice, yeah, but it's not what I asked for. So, we do exactly as you say. We draw and we know that's a first order reaction. Absolutely right. So we draw a graph like that, and obviously you will do that much nicer. My curves are a little bit, or my straight lines are not that straight. So we've got time and ln of the reactant. Okay, what's the unit for these things? What do I need to put in terms of unit on the axes? Minutes? Where? On the y-axis? No unit. Excellent. ln doesn't have a unit. Yeah, forget units. Never put a unit in, because otherwise my pen will weep red tears. Time, obviously, we put in minutes. Okay, and what does the graph look like? It's a straight, it should be a straight line, absolutely. Up or down? Down. Can it go into the negative range? Yes, excellent. Hey guys, you're good. So it's a straight line. So all you need to say is, it's a straight line, and therefore it's a first order reaction. End of story. Please don't write any books. Right? Sorted. Job done. Sorry?
Can we write novels instead?
You can write a novel, yes. If you don't really have anything better to do, I tell you what, a friend of mine who was absolutely lousy in chemistry when at university, he wrote poems in the chemistry exam. And in one exam, he missed it by 10 points or something like that, the pass mark. And the professor pulled him out and said, you know what? I really liked your poem, so you get the 10 marks for your poem. I thought, that's not fair. Who wants to read a poem in chemistry? I want, actually, but... Okay, so the next question in this case here, and that comes back to what you suggested, write down the rate equation for this reaction. Yeah? And the easiest way of dealing with that is you just simply say we have got a reactant like that. And we just simply say rate equals plus or minus. It must be minus because we use up the reactant. So minus K times concentration of the reactant. What's the rate order? Yeah, it's a first order reaction. Yeah? 10 marks for that. I guess even my cat could do that. Easy. Right. Then the next question would be, from these data here, calculate the rate constant. Do not use the graph. Why do I say don't use the graph? Bless you. Exactly. You could have effed it up, and therefore it would be wrong. So let's do the calculation. Actually, the reason why I want you to do the calculation is a different one, because this module, one of the learning outcomes is that you can use mathematical equations and can rearrange them. So that's why I ask you to calculate this. Okay. How are we going to do that? So here are the data again. First of all, let's write down one of the equations for a first order reaction, right? So we said we could use, for example, ln r at the time t divided by r at our starting time, let's call it r0, equals minus k times t when we observe the reaction minus t when we start. Yeah? So that's that. You get marks for that when you write that down, even if the rest is rubbish. So please share with me your thinking. Right. Now we've got a nice equation where we've got a k in it. But what do we do with it? Well, actually, what we can do is we can set up a little table. And that is my recommended approach. Whenever you do something like that, set up a little table. So, for example, you can say, I have an RT when I observe it, which corresponds with the time t. And I've got also an R0, which corresponds with the time 0. Yeah? Now, what can I use for that? For example, I can use, for the time that I observe the reaction, I could use this one here. Yeah? And the corresponding concentration. So I could use 60 here, and the time, oh, sorry. I got it the wrong way around. I have 60 minutes here, and the corresponding concentration is 24.8. Yeah, makes sense? And I can use a starting time. Now, unfortunately, you don't have at the time 0, this guy here, you don't have a corresponding reactant, do you? Bum. Actually, nobody says that we have to use the time 0 or 0 minutes, actually. We could say, well, we just simply start here. So this would be 10 minutes in, and we have a concentration of 111.1 millimolar. Yeah? We could start there. So, we've basically got everything. All we need to do is now a little bit of mathemagic and solve this for k. So we bring this to the other side. So we have ln RT over R, our starting time, divided by tt minus t0 equals minus k. So let's plug that in. Equals ln. What did we say? RT is 24.8 divided by 111.1. Obviously, we need to calculate that first. 24.8 divided by 111. And then do 60 minus 10. Make sense? The whole thing? Yeah? Let me see. I think I have done that before. Anyone got the calculator out? I see Anton is working very hard on the calculations. So I made this. I think I can do the denominator in my head. 60 take away 10 is 50. So I got ln of this thing is, so this is 0.223. Is that right? And ln of that is minus 1.5. Yeah? Ah, I'm good. Minus 1.5 divided by 50. So I can cancel out the minus. And that's good because we know that the rate constant, thank you, say it loud, is always positive. We cannot have a negative rate constant. We can have a negative rate constant if you are on the holodeck of SS Enterprise. But we are not. So positive. 1.5 divided by 50, that is k equals 0.03. Fantastic. What would be the unit? What would be the unit for that? Now we can start from what we know about units. What would be the unit for this part here?
Minutes at the power of -1.
That's the final unit. Yes, you're absolutely right. But what's the unit for the ln? ln doesn't have a unit. No unit. Exactly. So no unit for this one. What's the unit for time? Minutes, exactly. So we have 1 over minutes. So here, the unit would be 1 over minute. Or, as you rightly say, Janis, it is 0.03 minute to the minus 1. Yeah? Please, please, please do me a favor. Bear in mind that the unit for time is minutes, hours, seconds, or something like that. I know I'm insulting people, but I have seen in exam absolutely fascinating units for time. One was 1/hours to the power of 3.5. And you think, whew, wow, where does this come from? Right? It's a little bit like in the test yesterday, some people tried to sell me that 0.06, figure this number, 0.06 is smaller than 0.05. And they wrote that down. Can you imagine my reaction? I learned a new word from my son. It's called head disc. Yeah? So, if you think that something is nonsense, please don't try to sell it to me. I'm usually not that stupid, unless I'm completely drunk. Right? Likewise, what people sometimes do is, with a graph like that, they give me concentration of reactant versus time. Okay? Would be a zero order. So, they draw a nice curve like that, which is still okay, but not what I asked for. It's the pint of milk. And then they seriously do a line of best fit. Right? And they say, oh, the line of best fit is a straight line, so it must be a first-order reaction. My reaction is, I want to take this finger, stick it through the socket of my eye, and twirl inside my brain. Right? This is the reaction that this elicits in me. So please don't do that. Yeah? That's rubbish. Okay, let's go back to our problem. We've just calculated our rate constant. And the fantastic thing is, we've got the right unit. Hey, how cool is that? Okay, so now the next question is, how much of the reactant was present at time 0? Okay? What are you going to do now? Sorry? Substitute the values. Excellent suggestion, but you're not doing that. Anyone else? What's the first thing that you do? Oh.
Use the equation again, but k in this time. And work
Yeah, you could, but it's not what you do. What do you do? Any suggestions? What could you do? When you go to the supermarket and buy 3 or 4 items, right? Before you go to the checkout, what should you do? Check that you have enough money, that's right, yes. How do you do that? You look in your purse, yeah? But how do you know how much it will cost? Sorry? You estimate. Fantastic. Yeah? So why don't you do it here? Let's try to do a guesstimate about this number here. Okay? What do you think this number is or could be? Could it be 75? No, why not? It must be greater than 111, right? So it must be greater than 111.1 millimolar. Could be around 140, yeah, exactly. Yeah? So you know, yeah?
You can do like, because you know there's 10 minutes between 111
Yeah.
and 82.3, so you do the
Yeah, something like that. So it could it be 150? Could it be 10,000? No.
it depends on the rate constant, I think.
Yeah. But it's pretty unlikely, yeah? So we know a sort of a range in which this is. Why is that so important? Very often I see that people don't do this guesstimate, and they start writing and calculating like world champions. After 45 pages of calculations, they usually have forgotten what they want to calculate. And even if they haven't forgotten it, they come up with a number. This number is, for example, 0.45. Being so delighted that they got a number, they write that down in cold blood. Here's another head desk. Had you done the calculation, had you done the guesstimate first, you would have realized that it can't be 0.45. I usually don't penalize in this case for making a calculation wrong, for making a mistake. I penalize for being so stupid, not realizing what could really be. Yeah? So in this case, we know it must be larger than 111. It's probably smaller than 10,000. So now you guys come in, and you, and we now can use our equation and say, right, let's put that in. So we could use the equation, for example, RT equals R0 times E to the minus K times T of T minus T0. That was one of the equations that I showed you. And here we are looking for R0, don't we? So what we do in this case is, again, we set up our little table. So we say, okay, R0 and T0. What's T0 in this case? It's 0 minutes, exactly, 0. What's R0? We don't know, question mark. RT, TT, well, we can choose basically what we want. I usually go for something that I've calculated previously. So I would go for 24.8 and 60. And what was our K? 0.03 minute to the minus 1, exactly. Okay? So now it's fairly simple. All we need to do is just whack in these numbers. So RT is 24.8 equals what we are looking for, R0 times e to the power of minus 0.03, and we have 60 minus 0. Yeah? the reason why I'm harping on about this table is it's sort of just simply a scheme of work. If you do this table, you can't get lost. It's your safety net in an exam. Set up this table. What are you looking for? Indicate what you're looking for with a question mark. And what's the phrase? Robert is your mother's brother? Bob's your uncle? Sorted. So, we just simply can calculate it. 60 minus 0, that's 60 still. So that would give us e to the power of minus 1.8. Have I done that right? There. So, and that gives us 0.165. So we have 24.8 equals 0.165 times R0. Bring that over. And we have R0 equals 150. Pancakes? Millimolar. The Tonya was, yeah? Pancakes, yeah. No pancakes, right? Millimolar. Millimolar is a good unit for concentration, not pancakes. I fully agree with you, yeah? Especially with, say, Nutella. Yeah. So, 150 millimolar. What do we do now? We are not quite finished. Sorry? You do what together?
We can continue calculating the other thing.
We could continue. No, we don't. Loud? No? What do we do now? Yeah?
Basically, I'm thinking, because we got R0 to 150, can you put that into that equation when t 0, 0?
We could, but we're not doing that. What are we doing next? We've got 150 millimolar. It's great, isn't it? What do we do now? Yeah, loud. No. We check whether our estimate was right. Yeah? What did we get for the estimate? We said it must be larger than 111. Is 150 larger than... For some people it isn't, but in our case it is, yeah? So 150 is a potentially correct value. If I had 0.45, I would know that at one point I've screwed up somewhere. Yeah, makes sense? What do you do when you realize that you screwed up somewhere? Yep, you look through the stuff that you have written. Sometimes it is just simply you got a signage wrong, or you did, instead of multiplication, especially when your handwriting is not great, sometimes your plus signs get a little bit tipsy and they look like a multiplication sign. What do you do if you just simply can't find the error and the mistake? Save your life. What do you do? Sorry? What would you do? Move on, yeah? But please tell me that you spotted it. Because otherwise I go head desk again. Yeah? If you get 0.45 and you said it should be 111 or more. Write down, I made a mistake somewhere, I can't find it, but at least I know that you thought about it. Yeah? That's very, very important. Please give me that. Because otherwise I think you are a complete moron. Okay? Happy with that? Please follow these rules. Right. So, I've got a few minutes left. So we have K equals 0.03 minute to the minus 1. And I want you now, you can do that in groups if you like, I want you now to calculate this beast here. Right? Let's see if you can do that from what you just learned. Okay? Give you about 5-6 minutes. Please do that together, teamwork. And if you've got any problems, hands up, I'll sort you out. First of all, what did you get? 45 point. I calculated it to 45.2. Yeah? But if it was a test situation, I obviously would be happy with anything between 43 and 47 or something like that. And obviously you've done your guesstimate, so you know in this case it must be smaller than 82.3 and it must be bigger than 24.8. Yeah? And then you just simply set up your table again. You say, right, how will I treat this here, this one? I can treat it in two ways. I can treat it as an R0 and treat this then as my RT. That's one way of doing it. Or I can treat this as my R0 and treat this one here as my RT. Whichever way, as long as it's the right way, I don't care. So let's treat it like, from this one here, and set up the table. So let's say RT, that's what we want to know. The T, the corresponding T is 40 minutes. And in the table, you can be a little bit sloppy. You don't have to put the units down, but if you do, it makes life easier. So I probably should do that here. And millimolar. And R0, it is 111.1 millimolar. And T0 is 10 minutes. So I just simply plug these numbers in. And I get RT equals 111.1 times e to the power of minus 0.03 times, what is it, 40 minus 10. Yeah? Have I done that right? I hope so. Equals 45.2 millimolar. What do we do now? Check, is it within the guesstimate? Answer is yes. So most likely, yeah, well done. One question that's not in there, and the T you can do yourself then, sort of a little bit of homework. We have, I told you, or we just calculated, K equals 0.03 minutes. what is the half-life of this reaction? I told you very often, especially when we look at radioactive decay, we don't use the rate constant, we very often use the half-life of something. And we said half-life, T half, equals, anyone? ln2 divided by k. Yeah? Please remember this equation. And in this case, ln2 is 0.693 divided by 0.03. And we get for the half-life, can somebody do the honors? 23 unit? Minutes, yes. Again, we are looking for a time, a half-life here, time. There's a T in it. So the units must be minutes. Not minutes to the power of -2 or something like that. Doesn't make sense. It's minutes. This is one of the most common mistakes in exams, where people just simply write down 23. That's if they want to avoid the sticky issue of a unit, which is like Christmas without turkey. Yeah? Unit without a number without a unit is nothing. You're just weird.
I'm from Sweden. We don't celebrate.
Okay, Christmas without fish. Can you imagine that? So it's like, okay, it's like a birthday party without a birthday, right? Doesn't exist. Got it? So please put the units in. And when it's time, it has a unit of a time. Seconds, hours, minutes, years, months, fortnight, God knows what, but it must be a time. Okay? Happy with that? Any questions? So you can do that for the exam. For question 3. No, I didn't say anything, right? Because that 2011, 12, 13, 14, 15, 16, it always comes up. Not anymore. You don't trust me. Oh. Oh, okay. Okay. Thank you very much and have a lovely weekend and be good. Or? Oh, that or wasn't directed at me.